Hey, welcome back. It is time to do another 3D design. So I'm still in the process of building this quadcopter, and each time I go to do something, I find the typical installation method to be not ideal. It works, and a lot of people do it, and they get by fine, but something just bugged me. So typically what people do with their video transmitter, which is what this is, it's a little 5.8 gigahertz, 25 milliwatt transmitter. They'll just zip tie it. And I did originally zip tie it with some of these 3.6 by 200 millimeter cable ties. It's okay, it's just that the bigger zip ties that can go all the way around this are thicker, and it's hard to get them flush against it because zip ties don't like to take 90-degree corners or any sharp angles. And so then I put foam down, which is what this remnant is. I'll probably get some acetone or something and try to clean that off. Though I'm not sure if acetone will delaminate the carbon fiber, because carbon fiber is, it's a woven carbon fabric put into layers, and then they soak it in like a resin that hardens, and so I don't know if that resin will melt with acetone. I would imagine it'd be safe just to put it on there to soften this crap up, remove it, and then use alcohol to clean it completely off, and then I'm sure it's fine. But I don't know. I might just take a razor and try to scrape that off to be safer. But point being, I put some foam on there and then tied it down. But the thing is, these things, I don't know if you've seen videos of them, but they are really fast and they change directions ridiculously quickly. I mean, they'll be flying 60 miles an hour in one direction and then come to a complete stop, in under a second, and then fly around in the other direction. And it's a lot of G-force, and without too much force, I was able to get it to twist just like this. And obviously that's not ideal because the propellers are here, and if it goes far enough, it could. I mean, it would have to go pretty far to do that, and I don't think it would, but I'd rather play it safe. And this would be a super easy one. So I was thinking, make some kind of a cradle. So these straps, or these little slots right here, are usually for battery straps. So the company that makes this, I think they suggest that even in their picture it shows you put the battery back here and then you strap it on right there. But that puts the battery weight too far back, in my opinion. I would rather have it more centered. But the problem is you have to have the flight controller centered because it has the IMU. And you want nice, even readings front to back. And obviously if you put weight in the back motors will have to do more work to keep the back end level versus the front motors, and you lose total power because these motors will max out before those because these are carrying more of the weight. So I decided to put the battery on the top plate, dead center, and the top plate has these slots as well. So I could put the battery up here, no problem. Actually, it goes this way. But see, these holes are for SMA, and so a lot of people get a 90-degree connector, and then they'll put their antenna here for the video transmitter, which is okay, but I would prefer put the video transmitter on the bottom here and then put the battery on the top to keep the weight nice and even. Plus, this gets the video transmitting antenna farther away from, see, this is what we made in that last video. It would get the receiver's antennas farther away from the video transmitter antenna, versus if I did it here, it'd be considerably closer, because this would be right about there. So not a whole lot, but every inch counts in this situation. So I decided to put it on the bottom plate. Well, since I'm not putting the battery here, these slots aren't going to be used for a battery strap. So what I thought I would do is 3D print something with a little notch or some kind of little thing that sticks out that goes into these slots to keep it square, and then it'll have like a little like an indent on the top part that this sits into. So then the mount itself, the transmitter mount itself won't move, and then this won't move either within it. So then that way they both stay perfectly square. And then I would just have to get some cable ties to just keep it down into the mount. Now, the problem is these video transmitters, even 25 milliwatt, which is really, this is about as low as I think you'll see anyone use for FPV like this. Even 25 milliwatt, I had this thing powered on with an antenna on because I know that's the first thing people will ask. With an antenna on, I powered it on for maybe 5 minutes, and the thing was very, very, very hot to the touch. And that's just how the video transmitters are. They're not super efficient. And so you want good airflow. Now the good thing is these will get forward flight, so there won't be anything obstructing the air. The top plate ends right at these back things, so it'll get nice direct air on the top plate here. But obviously the bottom and the sides will be covered by the mount, but it's not really any better if I zip tie it here. Maybe the sides get a little bit more air, but yeah, I guess I could mount it vertically. That would be different, and a lot more surface area would be available for cooling. I didn't think about that. I might actually do that. I didn't. I don't know. I'd have to carry extra zip ties with me if I need to pull it out to change the channel, unless I leave this front part visible. I might actually do that, and then I can just mount. I'd have to unscrew this and then readjust the antenna facing up. But I think I'm going to do that actually. There you go. You're seeing me brainstorm live on video. Yeah, because that would leave a lot more. Because obviously, even if the ridges came up halfway, it's still covering half of the sides. And so all you get is the front and the top for cooling. But if I mounted it this way, I think I would be able to leave considerably more of the surface area visible. I'd have the entire top and bottom, except for the tiny little ridge around the bottom. And maybe at the very front or back, I'd have to have a little more coming up just to really keep it stable from flopping to one side or the other. But then it really wouldn't take much. And then I just need like one cable tie to hold it down into the thing. And that's the only direction that this would be able to move would be up. And I would have to have, it come around the front and the back also. But that might leave a lot more surface area available. Because if I put it down here, the entire bottom is going to be covered on the foam, and heat's not going to be able to get out of there. And plus, the little vents here are on the bottom, so I feel like mounting it this way would give it a much higher success rate for getting air cooling. I don't know. I'll probably design it this way, and then we'll try it. And then maybe once I mount it, I'll realize that it still covers up just as much, so I might as well redo it this way. Another thing I like about doing this is that the SMA connector is on one side and not the other, or not the center. And I'm really OCD. I like things to be symmetrical, so if I mount this centered, then it means the antenna comes off slightly to the left, and that bugs me a little bit. If I did it this way, it would be dead center, and the transmitter's dead center, and the antenna's dead center, and that would calm my OCD down a little bit. So I think I'm going to go ahead and just try it this way. If it doesn't work, it doesn't work. We'll reprint it. It's such a tiny part. This will probably print in like 10 minutes, so it's not that big of a deal. And it should be really, really easy. There's not a lot of complex geometry or anything going on here. So yeah, let's head to the computer and start designing. Alright, so let's take a look at what I designed before I show you the finished product, because I noticed that it's kind of hard. It's, I print everything with black because it matches the theme I'm going for with this quadcopter, and it just makes it hard to see detail and see what's going on in the actual video, so I thought I'd show you in here. So as you saw, I kind of mocked up what the video transmitter looks like roughly. It's just something I like to do. Obviously, I don't have to make it look. I could have just done a rectangle and it would have been fine, but it doesn't take that long, and it kind of helps. You need to know where the connectors are, where the screen is, where the button is. That way, you can be sure that whatever you build to hold it doesn't interfere with its operation, whether it be where the antenna comes out, where the cables go into it, where the screen is, so you can see what channel or band that you're on, and you have access to the button. So I like to mock things up, so I went ahead and mocked this up. And as you can see, it sits down in there, and I left a gap right here to where you can still see the screen, but there's a lip around the entire rest of it to keep it nice and snug. And so, as you can see here, it sits down in there pretty far. So the lip, or the inset's about 3.2 millimeters. So it's not super huge, but it's enough that and it fits really snug. It almost snaps into there in real life, the print versus the actual video transmitter. So it fits very, very snug. And even without, I mean, obviously this would, as it heats up and as it loosens and I use it, it's going to loosen up. But right now, I mean, it snaps in there so tight that it would take quite a bit of force to pull it back out of there. And as far as what keeps this from sliding around in the plate, I made these little things. Now, it's hard to center stuff, but I gave a little bit of wiggle room because stuff you print usually comes out just a hair bigger than what you're wanting it to be. I don't know if it's the settings or if I need to calibrate my printer, but I needed a little bit, and actually with this much of a gap, so less than a millimeter of extra wiggle room was just about perfect, because in the real one it kind of snapped into place, and it does fit very perfectly, and I'll show you. So I have some on the sides to keep it from sliding from left to right, and then I have these from keeping it from sliding forward or backward. And really, I probably could have gotten rid of the back part, and there's a lot I could have done to make this lighter and smaller. So if I ever publish any of these, I'll probably come back and refine them a bit, like round this corner off a lot, or even do an angled cut. Yeah, maybe an angle across here, because really this is a lot more material than is necessary. And with these racing quads, weight's pretty important. You want to keep all the weight down. And so these are what, 3 mil? That's way overkill. I'd probably cut that to like 1.5 mil for all sides. And even if going with 1.5 mil would be weaker, it's actually okay, because having something that'll break and give could potentially save something expensive, like a video transmitter. Yeah, they're like, actually, yeah, they are kind of expensive. They're like anywhere from 30 to 60 bucks. Actually, I mean, they go up even higher, but I think this one is probably like 50 bucks. But yeah, $50 transmitter versus 50 cents worth of plastic. I'd rather the mount break. So yeah, if I go back or decide to reprint this, I would probably go a little lighter on the materials in the bottom. Printing this is a pain in the rear because of support material. And actually, that's what I hate about MakerBot. They force updates on you. When you close it and then there's a new update, when you close it, it basically initiates the installation of the new update. And between the last time we printed and this time, they changed things again. They added different settings for the infill, and whatever I was using before, which worked perfectly, after the update, it doesn't. So I went and had to change some of the settings for not infill, I mean for the raft. Not for the raft, the support material. I printed the first time, so the inside part here was a hair too small, and the video transmitter would not fit in it once I printed it. I'm talking in real life here. So I decided that I had to reprint it. So the problem is, though, that because of that I would have had to reprint it anyway, but I couldn't get the support material out because I printed it to where this is, basically on the build platform. And so I had to put support material between all this stuff. So first problem I had is that whatever changes they made to their software, the higher support material number I use, which is, I think I set it to 40% is what I was using for the last several prints. I could not get the support material off. It was fused into the main thing, and I was trying to tear it apart, and it was ripping layers and individual strands apart, and it was just a mess. And so when I fixed this, actually, let me switch this to, when I redid this top piece here, and actually I'll just move it apart here. So whenever I decided to reprint this, the mount, after I widened this top part, so this fits a little better because I couldn't get it to fit in there, I changed the support material settings. So let me delete all these stupid guides. Oh, I missed the line, damn it. That bugs me. Well, it still printed fine. So I turned the support material down to 20%, which is what MakerBot's default recommends, and it actually worked okay. I was able to get it off. I mean, it still leaves crap on there, and it kind of sucks, but it's really more of a limitation in 3D printing than it is the fault of the printer. So, yeah, but once I reprinted it, it worked fine. So these snapped into here to hold the mount in place, so it won't move at all. This fits down into the recess here to where it won't move in respect to the mount, and then it all stays together because I punched a hole through here and here, and I made sure to get this angle perfectly to where it's angled right for a cable tie to come from here up over the top, and it did seem to work okay. It fit fine, and those holes will go through these slots right here and right here on both sides. And so I already have it mounted, so let's go to the bench and I will show you what it looks like completed and mounted exactly the way it's going to be permanently, assuming I don't decide to reprint it with less material, since this is a little bigger than I was hoping for, because weight savings is huge. But I might leave it, who knows, it depends on how lazy I am. Alright, and here we are, the finished product. So as you can see, the mount's a little bit big, so like I said, if I'm not feeling too lazy, I'm already procrastinating a lot with this build. This might be the longest build I've done, just because I keep doing one tiny little thing at a time, and then plus, I'm wasting a lot of time doing these 3D print things, especially making a video about it. It makes it take about 3 times as long as it should, but I'll probably reprint it with a lot of the excess material that's really not a part of the physical structure, that won't affect its rigidity. Pull that stuff out, maybe around a little bit, make it look a little nicer. Maybe thin this top plate, because that's pretty thick. Might thin that down by maybe 0.5 mil, maybe 1 mil, and I think that'd be perfect. But as you can see, I just used the standard, was that like a 3.5 mil, 3 mil cable tie. It's one of these guys. I just put it through, and I mean, I can pick it up by this thing. It's very, very solid. And I already remounted the antenna on there, as you can see, so whenever I'm doing, I don't know which direction, whenever I'm doing forward flight, this will still be just about perfectly up and down, because that will affect the polarization. Yeah, the screen clears. Screen clears perfectly. I can still access the button to change channels. The cable comes out without getting in the way of anything. And yeah, and as you can see, everything kind of fit in there perfectly. I mean, it really did kind of snap into place. So yeah, I'm glad I gave it the like, what was it, 0.7 mil wiggle room on each side of these things, because it fit perfectly. Once I snapped it in there, even before I put the cable tie in, the mount was snug, the video transmitter was snug. Obviously, you wouldn't want to fly like that, doing some violent maneuvering, and then obviously the plastic might start to get a little soft from the video transmitter getting pretty warm during flight. That might affect it, so obviously I'm still going to use a cable tie, but nonetheless, I think it's a success. I didn't really know what to expect. It's kind of one of those things where you just go into it knowing roughly what you want to build, and then you just start designing, and then you kind of make a couple design decisions in the process. Sometimes you go back and change some things, but all in all, I think it turned out all right. Now that I've got this mounted, now I know the perfect lengths to make these, because obviously it's way more cable than I need. So I'm gonna actually permanently splice these together with just enough wire on both ends, and then this will have to go down to the bottom where the PDB is going to be, and then give it some power And the camera actually gets 5 volts from this. This is a linear regulator that regulates down to 5 volts just for the camera, for the sake of the camera. So that means I can power this directly from a battery. It's got a really wide voltage range, and I'll be running a 4-cell. I think this will go up to 20 or 25 volts. 4-cell is only like what 14.8 volts nominal, so I can power this straight off the battery. It'll regulate that down to 5 volts for the camera. But now that I think about it, though, 14 volts down to 5 volts on a linear regulator is going to put out some serious heat, and that actually might be why this got so warm when I was testing it the other day. So maybe I'll power the camera directly off of the same 5 volt rail that the receiver and the flight controller will be on. That way we eliminate the heat from this, because I don't want to get too hot, especially with a PLA mount like this. This stuff melts at like 200 some degrees. Well, it starts getting soft at about 200, and I print it at 230, so I don't think it'll quite get that hot, but, well, it could. I don't know. I'm just rambling on at this point, so I'll probably stop. But yeah, I just wanted to show this off. I thought it could be interesting to some people out there. Yeah, but sorry I keep doing this. It's just, this is the current project. You know, when your bench has a bunch of crap on it, you got to finish one project to be able to start something new. So yeah, it's probably got to be, hopefully this will be the last 3D printing video, and I'll do something else for the next video. I don't know. But anyway, I will see you in the next video. Bye.